I'm going to be walking you through an introduction to data analysis and ecology. So if you guys haven't met me yet, my name is Mac White, and I'm going to be your TA this semester. I will be working with Dr. Combs to help teach all the labs. More than likely, I'm going to be the one that is in labs working with you guys and grading these assignments and things of that nature. So if you haven't met me yet, I'm sure we will soon enough. But anyways, today I'm just going to do a quick tutorial on how to analyze some of the data that we're going to be working with this semester, and also how to present some of those results that we're going to be getting. So this is a pretty important exercise in my opinion, because it's going to set that base for a lot of the work that we're going to be doing this semester. So that being said, I'm going to give a little introduction and then we'll just get right into it. So ecologists gather and analyze various types of data, so this exercise is going to be designed to give you guys practice in organizing ecological data, performing some simple stats, and presenting the results. So we're going to be using Excel today, under the assumption that most of you will be using Excel due to your data to do your data analysis, since it is so readily available and easy to use. So that being said, I want to make a point here is that if you don't have Excel, that you should be able to get Excel for your own personal computer online from the university. So Tennessee Tech should have somewhere online that you're able to get the Excel program and download it to your personal computer. And if not, a lot of the libraries, like the library and all the computers there and other computers on campus, should have this program as well, this application. So that being said, if you do have experience with other computer packages such as SAS or SPSS or R, you're more than welcome to use those. But that being said, I don't know really that much about SAS or SPSS. I'm pretty familiar with R and do a lot of my own work in R, so I could help you out there. But unless you're using Excel or R, you're going to kind of be on your own. So I would encourage you to use Excel. It makes it easier on both of us, and if you want, you can try R, that's fine. And I should be able to help you out there too. So the goal for this exercise, like I said, is pretty easy. It's pretty simple, that we just want to practice our data analysis techniques and how we're going to present these results throughout the semester. So with that being said, you guys will be provided 15 individuals from each of two species, 15 individual measurements, from each of two species. So yes, 15 individuals. And so for each of those, you're going to have total length and head length. So that being said, you should have 30 measurements for both total length and head length, and 60 overall. So measuring fish lengths. So while we're not going to be measuring the fish used in this exercise, I have provided the techniques for you below. So just in case you're interested in fish, or you want to work with fish someday or whatever, and you're just interested in how we got these measurements, I'm going to have the directions right here. So like I said, we're going to be using total length, which we can see down here in this diagram is just the length of the fish from the tip of the snout to the points of the caudal fin. So, and then we have the head length as well, which we'll be using, which is just from the snout to the back of the operculum. And so the operculum is just the bony flap that's going to be covering the gills, and that provides protection for the gills, which are obviously very important, as that's how fish acquire oxygen from the water column. So that being said, today we're going to be working with long-nosed dace and blunt-nosed minnow. And this figure right here is neither of those fish. This is a bonefish, which is a marine species. And these are both freshwater fish that we could find here in Tennessee. So that being said, we're going to collect data to address the following questions off of these fish today. So is there a difference in body size between the two fish species that we measure? And is head length related to total length in fishes? And if it is, how so? So you guys are going to be provided with a template for this exercise as well that will kind of help you guys work through this and be able to kind of let you figure it out kind of for yourself while watching me as well do it. So that being said, you're going to be getting a template that's going to look just like this, a lot of blank space, but we're going to fill it in and answer all these questions here at the bottom. We're going to go through all these steps in hopes of finding some answers to our two main questions. So that being said, if you don't have Excel, pause the video, go download it offline from the university. And then another note is that you should have downloaded the data analysis tool pack already. If you do not have the data analysis tool pack, you're going to need that for some of our analyses. So it's just going to be Something easier if you just pause the video again right now, go find that. If you guys don't know how to download to get the data analysis tool pack, just look it up on YouTube. It's really simple, and you should be able to find an easy, intuitive video on how to get that data analysis tool pack into your Excel application. But that being said, we'll go ahead and get started with some of these. So the first thing that we're going to want to do is going to construct a table in Excel. So what I'm asking is that you guys just do TL or HL for each species. Like the point of this assignment is just so we can start understanding what we're expecting of you and how you can meet those expectations and like what steps you need to take in Excel to get there. So the first thing I'm going to do is do total length for Rhynictes cataracti, and so here we see that. So I'm just going to select all this, move it over to the table, and so now you see here this is going to act as our like our table's like title, and then these are going to be our different headings for our different rows. So right here we can see Rhynictes. I just want to make a quick note about this. So with like the genus and species names of a scientific name, there's some specific syntax that we need. And so with that being said, the syntax that we're looking for is that our genus is going to be capitalized and our species is going to be lowercase. And then also that all genus species names are either going to be italicized or they're going to be underlined. Not both, just one or the other. So I like to italicize mine, but it's each person's individual preference. It doesn't matter. So here, like I said, we're going to have our heading for our row. This row right here is going to be the head, our title for our whole table. So the first thing that we want to do is make sure that we have a descriptive title. So here we have our genus species name written out correctly. What are we looking at here? We're looking at the total. Oh, we don't want that to be italicized. Total length in millimeters of Rhynictes cataracti. So as you can see now, the column here, the row here is a little bit longer than these other ones. So we want to kind of spread this out here and kind of even it up. So just bring it about halfway across the title row for the table. That looks pretty good. Everything up here looks good. I like to left justify my stuff just to fit with the title. It doesn't really matter. Like I said, the big thing at this point is that we have the genus species written out, descriptive title. We have our column headings for these different columns. And now we're ready to go to the next step, which is going to be to get rid of these grid lines. These grid lines are not very attractive. It looks like we just pulled it right out of Excel if we were going to post this into a Word document. And we don't want that. We want it to look clean. So your initial response might be to go to the border, but there's already no border here. To get rid of the grid lines, we're going to go from no fill to just a white fill. Okay? So the big thing so far is that genus species is written correctly, and we have a descriptive title here. So those are the two biggies. Alright, and now what I like to do is kind of come in here and throw some borders in, and this is what we're going to be expecting of you as well. And I'm actually going to go ahead and merge and center this as well. So the reason that we want to have these borders in here is so it kind of separates our data and just makes it a little bit easier to flow, like the flow as we read down it. Just makes it a little bit easier. And so I like to draw my border. So to draw your border, all you got to do is come down to line style, pick your line style and color, and go ahead and throw those borders in there. So we're just going to have a border that separates the main title from the column titles, the headings for these different columns, and then one that kind of completes down here to kind of show the bottom of the table. So this is what we're going to end up with. To get away from drawing the border, you just have to hit back on the border here, and this is what we're looking for. So, yep, those are the important things for a table. So we don't want to have grid lines. We want to have these 3 borders, or just kind of borders in general, just to kind of separate things and make it look smoother. And then we also want to have a descriptive title. Another thing I want to mention is that we're using units of measurement here. And so right now we see that we have millimeters, which is fine. But if we didn't have these, total length could be anything. It could be 80 feet. And if that case, we're talking about whale sharks. But now that we're put millimeters in, we know that we're talking about something pretty small. So this is just going to give us a little bit more information. When we have to make sure that we always put our measurements in when we're talking, our units of measurement whenever we're talking about a measurement. So this looks good. I'm going to go ahead and actually just write total length in here, since we have not anywhere in this table indicated that TL equals total length. So there we go. Looks pretty good. Alright, so now we got that done. Next thing we want to do is calculate the mean, the variance, and the standard deviation. So this should be done separately for each species, and be sure to organize our answer so it's clear what each individual measurement is, and what measurement of mean or standard deviation or variation and which measurement that's for. So I'm just going to do it right here. So for our mean, we're going to put an equals average. We're just pretty much making a function equals these rows, enter. So that's going to be our mean. Standard deviation for the total length of Rhynictes cataracti, going to equal standard deviation, so STDEV. Once again, just add these. And our variance, equal var, VAR. Alright, there we go. And then what you can do here is just drag these across, and that's going to give you the mean for each one, standard deviation for each one, and the variance for each one. So whenever you guys do this, you might initially have something that looks like this, a lot of decimal places. We only want to go to the second decimal place here. We don't want it to be any finer resolution than this. This is plenty, and any more than that, it just kind of starts to look messy. Alright, so we have that done now. Next thing we need to do is construct a bar graph or column diagrams according to Excel that compares the mean total length values for both your species. Once again, your figure should follow the appropriate conventions. So we're going to go over what's important for these bar plots too. So we see here we have Rhynictes cataracti, Pimaphaleus notatus. What we need to do is bring these over. Let's see what measurement we're using. We're going to be using mean total length. So let's grab the total length of each species. Copy that over. There we go. See, it calculates the mean and the standard deviation for us once again. So these numbers should be the same, which they are. That's good. Alright, so now the next thing that we're going to do is insert our bar graph, or our column graph. So here you want to do a two-dimensional column. Go ahead and delete that. Insert. So we'll go ahead and select our data that we want. So remember, we're going to be comparing the means. So you don't need to select all this. We just need to have the two different species and then their means. So let's see what we got here. Yep, that's pretty much what we're looking for. So I'm just going to make this a little bit bigger so I can see it. First thing I notice, these aren't italicized, so let's go and italicize these. Text options. Let's see. Italicize. There we go. So now we know what that's for. We just have kind of our basic chart. So our next step is that once again we want to have an informative title. So right here we're comparing the mean lengths, not only the mean lengths, but the mean total length in millimeters of 2 cyprinids. So cyprinids is just short for Cyprinidae, which is a family of fish, and both of these fish fall in that family. So this is kind of a short, meaningful title that lets the reader know what they're looking at. So mean total length millimeter of 2 cyprinids. Alright, and so we have our species down here, and then over here we have our mean total length in millimeters. Once again, these grid lines, don't like them, so let's go ahead. You just need to click on these grid lines and you should be able to delete those. Alright, then we have our measurements here. Next thing that we want to do is that we're going to go up to chart design, and this is the easiest way to do this, is just to go to add chart element. So what we need here is we need axis titles. So primary horizontal. So what do we got here? What's descriptive? So these are just let's just call it fish species. Alright, great. That looks good. Really tiny, so we'll actually make that maybe a little bit bigger. Alright. Then over here, you're going to need, if I was just looking at this, I'd have no idea. I could guess this is probably mean total length, but we need to have a title for this axis as well. So here, we're going to put mean total length in millimeters. Alright, then once again, I'm going to bump the size of this up a little bit so it looks good. Alright, let's go to 14. Nice, looks good. That kind of auto corrects. Alright, this looks good so far. So what we have here, and what I'm be expecting, is going to be, actually, one more thing. I'm going to change this. So just for simplicity, I would like to keep this, all of our stuff that we do this semester in black and white, as you guys will be printing it. It's just a good practice to try to keep things in black and white, but obviously if you just print it in black and white, it won't matter either. So here we have it, black and white. The big things here, just like with the table, I pointed out several things that we want to have descriptive title, right? A main title. We also want to label our axes, which we do. We want to get rid of those grid lines. And then one more thing is that we want to add error bars. Excuse me. So error bars is going to give us a sense of how much error there is in our estimate. So if we come here, we can just go to custom, we can specify our value. What I want you to do the standard deviation, so plus or minus each way. That's what this is going to be, so equals this. So did you see how I did that? It was a custom error bar. And so now each of these have different amounts of error, right, depending on which one you're looking at. Obviously they're not changing that much, but still you don't want to use a singular error bar for each. So going to custom and selecting your 2 standard deviations from over here is going to do that for you. So now this is what we're looking at, and this is what we hope to accomplish when we're coming in to do a bar graph. Alright, next thing that we're going to want to do is create a scatter plot. And here in a second at the end of this video I'll go through and I'll say for each one these are the most important things, and I would suggest that you guys make just like a note of that on a piece of paper somewhere or a sticky note or something, and just remember that for the rest of the semester. So for one of our species, we're going to produce a scatter plot using your total length and head length data. So you should put your total length data on the x-axis and the head length data on the y-axis. Again, your figure should follow conventions. Alright, total length, head length. Let's just go ahead and let's do Pimaphales this time. And say that like it's really like super exciting. Like just go ahead and do some Pimaphales this time. So, alright, that's what we'll do. So now we're going to go, and for this we're going to do a scatter plot. Correct? Yep. So we're going to do a scatter plot. So head length data on the y-axis. Yep, it all looks good. Great. So the next thing that we're going to want to do is going to insert a scatter plot. And the scatter plot is just going to be one of these plots right here. So we're going to go ahead, click on this. Oops, sorry, I didn't select my data yet. So let's go ahead and select our data. So we'll just do TL and HL. So usually we want to include at least one line of like heading, and then we can go in and it knows that that's just going to be the heading. When we do a data analysis, we'll have to mark it as such, but for graphs, it's pretty intuitive and it understands what you're doing. So here we go. We have total length and head length here. All right, so obviously down here we have our total length on the x-axis and head length on the y-axis. So this is pretty ugly at this point. So first thing we want to do, let's just go ahead and give it that informative title as like we usually want to. So here we're comparing total length and head length of Pimophales notatus, right? So head length versus total length of Pimophales notatus. There we go. Make sure that we know this is in millimeters. This looks right, just need to italicize it. Great. It looks better with just one. As long as we show here that what we're looking at, that's fine. So head length versus total length in millimeters of Pimophales notatus. Actually, you know what? I'm gonna take that out of this one. This title's too long. We'll put in that it's millimeters over here on our axis labels. So next thing we want to do, horrible grid lines. Get rid of them. Super ugly. All right, now that we've done that, when I'm looking at this, we see there's a lot of empty space here, and I don't like that. I think that it kind of skews what the actual relationship is here, and it just doesn't look good. So we can come in here, we can select these different axes options, and we should be able to come in and yeah, axis options, under axis options, we should be able to change the values. So for this one, it doesn't seem like it really starts till 3. So we'll just go ahead and do the bounds as, we'll start it at 2.0 and then end it at 10. There we go, so that brings that more into focus. And here, this is where a huge issue is, right? So we'll come down here to this axis, minimum 0, maximum 100. 100 looks pretty good to me, but maybe we can bring this down to 50. That's where we'll start our minimum at. Yeah, so that looks much more linear in there, and that looks a lot better. So I like that. So with that now, this looks pretty good at this point. We just need to add some titles to our axes. So chart design, primary. This is going to be, remember, our total length. And then here we'll make sure that's known that's in millimeters. Then up here, primary vertical. This is going to be head length, also in millimeters. Once again, I'm going to bump this up. Bump that up to about 14 because it looks so tiny. Alright. For all of these, I'm just going to go ahead and change the fill to black. Alright, there we go. At least I think that's black. Oh yeah, it is. Just the outside of it is not any longer. So we want the outside of that to be no outline. There we go, that looks better. Uh-oh. Give us our grid lines back. So once again, to get rid of those grid lines, delete, delete. Alright, that looks good. I'm happy with that. So really this is all that you need. If you want, you can insert some other elements as well. I kind of personally like a trend line. So let's see what our linear relationship is. So if we want, we'll go ahead and add that trend line, and we can kind of get an idea of what the trend is and how linear that is. So yeah, this is all you need. So for a scatter plot, what we want to see is just like the bar plot. So we want to have that informative title. Oops, almost forgot myself. Here you go. Italicized. Informative title, everything looks good. And our axes titles look good. They tell us what the unit of measurement is. In black and white, we have none of those ugly grid lines, and it's kind of full. So remember, we had all this empty space, and now it's full. So this is what I'll be expecting out of a scatter plot. Alright, so now into the stats. So now we're going to perform a t-test to determine whether two species differ in total length. So for this, we're going to use the t-test, two sample assuming equal variances option in the Excel data analysis tab. And so it wants us to provide the complete Excel output from the t-test as part of your work. Alright, so here we're going to do a t-test whether they differ in total length. So we're going to bring the total lengths again from the raw data. So total length, total length. Alright, there we go. So now let's go over here to data analysis. Remember, we want the two sample assuming equal variances. So let's go ahead. Now we see this. This is what we get. Just for ease, I'd go ahead and clear these out. These are just the ranges of the inputs that we're going to put them in. And then our output range. So go ahead and clear that out too. Make sure that labels is selected, because that means that we can use this first row. So we know what we're looking at, which and it's just we need to have those labels, or it's going to try to use this as a value and it's going to mess it up. So for our variable 1 range, we're going to use Rhynictes cataracti. So alright, that's variable 1. Remember, we have labels included, so we're able to include that label. Alright, variable 2. Alright, great. We don't have to do this. We don't need to put a hypothesized mean difference in. But we do want to set our alpha value to make sure that our alpha value is set at 0.05. So this is when we talk about p-values, which you've probably heard of before. This is saying that this is going to test for the significance at 95%. So 0.05, we move this to the right twice. That's 5%. So 95. We can save 95% confidence looking at our p-value, whether or not these are significantly different or not. So whether the means of these two groups are. So our output range down here, and just hit OK. Alright, so here we just have some basic summary statistics for both of these. Alright, and then these are just going to be for both of these together. So these are where we get more where we're looking at comparative statistics. So here we see our p-value 0.0029. That is less than 5, so we're going to use the one-tail p-test here. And so if you want, I'm going to go ahead and fill this in, kind of highlight this section here. So you can see here that this means that the means of these two groups are significantly different in total length. Alright. So pretty easy. The next thing I'm going to do is perform a correlation to determine whether head length is related to total length. So for this test, you should use the correlation option in the Excel Data Analysis tab. So let's see, we're looking at one species to see if the head length is related to total length. So raw data, let's do Rhynictes this time. So this is a long-nosed dace. So we might start to think that this one's head length is a little bit longer in relation to its body, but still it should be correlated if it's the same amongst all the different species. So here we go. We're going to have a correlation, so we're going to use the data analysis toolpack once more. So now that we're here, go ahead and hit correlation. Input range. It's going to be here. Grouped by columns, labels in first row. Output range is just going to be right here. Make sure that we got this selected right. All right. So here we have a value of 0.95. So this is just our coefficient of determination. And so with this being said, this is kind of like our R value or R squared value. So this is just how related are these two values. So this is going to be on a scale from 0 to 1, with 0 being absolutely not correlated to 1 being absolutely correlated. So here we see that we have a value of 0.95, and so that means that these are pretty correlated to one another, which is what we would expect if we see a similar relationship throughout the species. And that's why we see here this 1 TL to TL. Obviously, if you compare these side by side, it's going to be a 1 because they're the same exact numbers, same with HL. And this is the value that we're really looking for. So looking at your bar graph, your scatter plot, your t-test results, and your correlation results, how would you answer the two questions at the top of the page? Then what, if any, limitations are associated with the completed analyses? To answer this question, you should very carefully consider the wording of the questions addressed by the exercise. So is there a difference in body size between the two fish species you measured? So looking at our own data, I would say yes, right? According to our t-test, that we would be able to say that there is a difference in body size. They're significantly different because our p-value was less than 0.05, indicating that they're significantly different. The means of these two groups are significantly different. In addition to that, and just once again, remember we're answering number 7, is head length related to total length? I would say yes, definitely. At least in terms of our data, we would say that total length and head length is correlated. So what, if any, limitations are associated with the completed analyses? And you see here it says carefully consider the wording of this question. So when we do science, we can never extrapolate out past what we did. So here we looked at all this data from 2 different species, but we can't analyze all the data of every fish species, ever that has ever lived, that is currently living, that's extant, whatever. But we can say these things with significance based off of our own observations from our data analysis and from our results that we have given and presented, that there is a significant difference in the size of these 2 fish species. And then as well as that head length is related to total length, at least in these 2 fish species, or the fish species that we looked at, which was Rhynictes cataracti, right? So this is what we're going to be using a lot this semester in Excel, doing some of these little easy data analysis techniques and doing a little bit of stats and presenting bar plots and scatter plots and tables and stuff like that. And you should always be told what we're expecting you to provide us. So I'm not expecting you to look at a data set or a question and determine whether or not you need to run a t-test or a correlation. I'm going to let you know that. But then I want to see the appropriate conventions used that we've talked about in this tutorial. And then, so with that being said, we have our table here. Once again, we're just going to look at these values that we have here, and that we see that the big 3 things that we want to do here is that we want to have an appropriate title, we want to have appropriate column titles, and then we want to have our borders, and then we want to have no grid lines. For our bar plots, what we're going to want to do is get rid of these grid lines once again, appropriate titles, and our standard deviation bars right here to give us an idea of some kind of error that we have. So to do this, like I said, what I want you guys to do is just do the one where you're able to make your own, right? So if we wanted to do this, let's go ahead and just click on this one more time. Format, chart design, add chart element, error bars, more error bars, and we want to do custom and then specify that with these values right here, which is our standard deviation. All right, here's our scatter plot, same sort of conventions that we're hoping for the bar plot, informative title, informative axes titles. We have our units of measurement, genus, species is written out correctly, and then the information is taking up the entire meat of the graph. And then t-test, really the only thing I really want you guys to report to me this semester is your p-value, your one-tailed p-value, unless I say differently. And then with correlation, this is just going to be your coefficient of determination, which is 0.95, which we can begin to think that these are very closely correlated. So that is all. If you guys have any questions, email me or get in touch with Dr. Combs. Thanks.